Assalamu alaikum. This is Haleema Sidique along with my partner Saba, and today our presentation is on process control block. So basically, what is process control block? A process is a program in execution. The execution of a process must progress in a sequential fashion. It starts with a ready state where all the necessary resources are available, and now the process is waiting to be assigned to a processor by the operating system. Next slide. A process control block keeps all the information needed to keep track of a process. It is basically a data structure with many fields. At first, we have the process ID, which is the unique identification number for each process. PCB has 4 process states: new, ready, running, waiting, and termination. Pointer contains the address of the next instruction to be executed in the process. The process priority and pointers to scheduling queues is the CPU scheduling information that is contained by the PCB. Process privileges are the special accesses to different resources to the memory or devices that the process has. Next, we have the CPU registers that store the state information of a process if any interruption is to occur. Accounting information is the amount of CPU used for process execution. And at last, we have I/O status information, which includes the list of I/O devices used by the process. Next slide, please. Elements of a process in main memory: stack, heap, text, data. Note from the figure here that the stack and the heap start at opposite ends of the process's free space and grow towards each other. If they should ever meet, then either a stack overflow error will occur, or else a call to new will fail due to insufficient memory available. Next slide, please. Saba Khan will continue from here onwards.
States of a process. A process may come into the ready states when starting execution or it was running or interrupted by the scheduler. Waiting state. If a process needs to wait for the resources such as a user input or a file to become available, it goes to the waiting state until the necessary resources for execution are available. Terminated. Once a process finishes its execution or is terminated by the OS, it is moved to the terminate state where it is waited to be removed from the main memory. Multiprogramming. Suppose a process is currently being executed and an interrupt occurs, telling the OS to switch process. The OS will save a state of the process currently being executed in PCB, reload the state of the new process, and start execution. What causes a process to switch? Clock interrupt. When a process has executed for a maximum allowable time slice, I/O interrupt when an external device informs the CPU that it is ready for the communication request for the attention for the CPU. Memory fault. Memory address in a virtual memory, so it must be brought in the main memory. Trap. When an error occur or exception occur, there may be cause a process to be removed from the terminated state. Supervised call, such as open file. Process scheduling. The OS maintain all the process control block and process scheduling queue. The OS maintain a separate queue for each of the process states and PCB of all the processes in the same execution state. When a state of the process is changed, its PCB unlink from its current queue and move into the new queue. Job queue. This queue keeps all the processes in the system. Ready queue. This queue keeps a set of all the processes residing in the main memory, ready and waiting for the execution. A new process is always put in this queue. Device queue. The process which are blocked due to the unavailability of the I/O device considered in this queue. Below are different times with respect to the process. Arrival time. Arrival time is a point of time at which a process enters into the ready queue. Completion time. Completion time is a point of time at which a process completes its execution. Burst time. Burst time refers to the time required in a milliseconds by the process for its execution. Turnaround time. Turnaround time is the total amount of time spent by the process in the CPU. Waiting time. Waiting time is the amount of time spent by the process waiting in the ready queue for getting the CPU. Thank you.